Welcome back to the Automation Podcast, the world's #1 industrial automation product and technology show. Thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience, and thank you for tuning back in this week. And we got a special guest on this week, Aidin Allyarzadef, and he is from Schneider Electric, and he's here to talk about digital twin-powered physical AI. It's a very interesting conversation. He talks about what he calls automation to autonomy. And I thought it was very interesting and really enjoyed listening to it a second time when I went through and edited it. And I think you guys will enjoy it as well. But before we get to that, I do have one announcement. I want to thank Schneider for sponsoring this episode so we can release it to you completely ad-free. If you see anybody from Schneider, please thank them for sponsoring this episode. With that said, let's go ahead and jump into this episode and learn all about digital twin-powered physical AI and the journey from automation to autonomy. Aidin, welcome to the Automation Podcast. I'm excited to have you on, especially the topic you're going to talk about. In our pre-show, we kind of talked about this a little bit, and it's an exciting topic I think the audience is really going to love. But before we jump right into it, let's go ahead and just have you introduce yourself to our audience, tell them who you are, what you do, and then you can jump right into the topic that we're going to talk about.
Thank you, Shawn. Thanks for having me. And I'm delighted to talk to you about the passionate topic. Engineering masterpieces are as beautiful as Mona Lisa portrait. This is Aidin Allyarzadef. All my educations are in electrical engineering, almost 30 years of working in industrial automation field since my bachelor, student in the bachelor, and then almost 20 plus years working at Schneider Electric in different entities and departments, global and local positions, sales, marketing, service, training, future marketing. That's why I've seen the business, Shawn, from different perspective, and I'm trying to usually understand the pain point and technology. And in my daily job, this is how I'm doing to address the pain points by technology, by Schneider solutions, and also third parties.
Sure. Excellent. Well, thank you for that introduction. And why don't you tell the audience what we're going to be talking about today? They already saw it in the title of the presentation of the episode, but go ahead and tell us what did you want to talk about today?
The topic, interesting topic nowadays, is getting very hot and popular. Title is Automation to Autonomy and Physical AI. AI, you know better than me, is a hot topic. However, all of them are not necessarily applicable in industrial automation field. That's why I want to link the digital twin topic to the physical AI enhancements and we discuss how, where, what, because if it's an engineering, we should be able to address the pain points, we should have the value proposition and so on. So this is in brief the title of this session. However, I want to clarify, autonomy doesn't mean removing the human from the automation equation. We will talk a bit more where and how we put the like a hardware in the loop, human in the loop. But in brief, at the beginning, I want to open it. That doesn't mean removing the human from this equation. Shawn, for this purpose, for example, if I want to say a few words about why what automation enhancement becomes autonomy, and why now, why autonomy and so on, I can say industrial automation is moving from the traditional approach, which is logic and everything is predefined, right? Sequence of operation is always predefined as a logic, and regardless of the devices, is always predefined. But now we are going to more adaptive, more complex, more autonomous in all aspects. We are not only industrial automation, we see in the environment around us also, we see autonomy, semi-pilot, autopilot cars, I don't know, even a vacuum cleaner at our home and so on. So this is the purpose of the of this topic. And now imagine we have a like a real-time digital twin replica of the system, and we shift from the real world, which costly time matters, cost matters, shortage of the how can I say, labor shortages, higher throughput demands, supply chain stability. That we passed the COVID and pandemic. However, for example, we had a year or so, we had the tariff topic. No, more or less we have the war topic. So these are the like a instability and fluctuation in the supply chain and so on. So means the automation system we design and propose to the people should be more agile and flexible to pass these fluctuations. Also safety of human as a first priority, growth of robotic cobots, collaborative robots, automatical guided vehicles, smart conveyors, and so on. Blind spot that humans, we are human and we make mistakes as a real life. Uh, mm, Sometimes this kind of virtualization and sit tight and sit back, not under pressure and so on, we can address and think better. High visibility in demand and need for faster commissioning, always room to improvement. These are the main reasons as a big picture why autonomy matters now. With this context, I want to talk and um, address these topics.
Yeah, there is a lot of things that, if we look over the history of just the last 50 years,
Mhm.
there's a lot of things in manufacturing that have changed
Correct.
because, the tools have gotten better, right? So jobs, people, well, even jobs I did in college, they don't exist anymore because the tools got better. We think even in our own personal productivity on a PC, right? Imagine before we had, Outlook or Act or any of these relationship management tools, we had index cards. We kept all those business cards that people would give us. We didn't scan them in. We had
Right.
to keep them in a drawer, and then we'd have to call like a silly person from the road if we didn't have the business card with them. We'd be like, "Hey, could you go on my?" So this has happened in the entire industry in every part of our lives. The tools have gotten better,
Agree.
and digital twins and AI are getting better. I mean, AI still makes mistakes when we're talking about large language models. I ask it questions quite often that it gets wrong, but it's based on the information it has. And as I research a lot of that information, the base information, the underlying information it's using is wrong, right? Obviously wrong. So that's different though when we're talking about a machine we're designing, a machine that we have all the SolidWorks, all the CAD drawings for, all the sequence of operations, all the parameters, all the inertial loads and speeds. I mean, we can really tune that in and it can be precise and accurate. And like you said, really reduce, commissioning time. But getting there, it's been a long road. It's not something that's happened overnight.
No, you are right. You are right. It's not happening overnight. It does have a learning curve, and however, in different project to project is different. However, we can prove that it supports the sustainability topic, and we depends on the project size. We can more or less save, but for sure we save a lot of time, energy, risk, and so on. You are absolutely right. And Sean, also the topic you mentioned on the CAD drawing. When I was educating, we did it with the pen and paper and tools and no, it's AutoCAD. No, it's right. So this is a revolution that is over the course of I don't know how many years it's happening, not over the time and in a heartbeat. But thank God we are part of this beautiful journey.
Yes. Yep, absolutely.
If I want to know, talk about to understand this topic, I divided the topic to the fundamental and then put the add-ons like a physical AI on top of it.
Okay.
And we talk about a vocabulary of what we are talking about. I hope I keep it short and sweet to not be boring for the people who are listening, but good to we clarify when I'm talking about emulation, what I exactly I mean when I'm talking about digital twin, because these terms are very broad and very how can I say, different use cases. In general, for example, I take the fundamental topic as a digital twin, and then we go to the physical AI.
Okay.
And then if I want to say what is digital twin, exactly twin, digital version of something, anything. So virtual representative representation of a physical asset, right? So this can be a, I don't know, data center. It could be a machine, could be a plant, could be, for example, digital twin of a refrigerant and a hydraulic and pneumatic, or physical topic like a gravity, I don't know, inertia, torque, and so on. Although to narrow it down a little bit, I'm talking about the second part. For example, this topic I'm gonna talk in the next hour or so will not cover the refrigeration, fan, pump, hydraulic, pneumatic, and so on. But our topic is very broad and same concept can applicable, but like for example, let me show you this Schneider variable speed drive is dedicated to HVAC pump and so on, or I have another one dedicated to the machine higher transient overtorque. What I mean everything is getting optimized for a specific application, and application knowledge matters, and it saves the engineering time. That's why I narrow it down to especially like a conveyor, logistics center, baggage handling, manufacturing, robot, AGV, AMR, and so on, rather than data center, fan and pump, and so on. Any questions so far?
No, that's great.
Usually I'm facing with this question that they are saying, how smart a digital twin can be, right? And I'm saying, okay, good question. All of us remember in our childhood, it's the Italian novel Pinocchio. And Pinocchio was from piece of wood during the life journey, became a human, right? He got wiser and wiser to become a human. So here, more or less the same story in a digital twin. Digital twin by itself is like a, I don't know, empty raw controller drive and so on with nothing. Uh, as soon as we fit the physical concept like inertia, torque, I don't know, friction, depends on the application. More and more we feed this physics engine, we can bring this 3D model, 3D digital twin model closer and closer to their reality. And then that's why some companies, it's still around the world, it's not 100% there, but so many companies accepting digital twin as a virtual factory acceptance test. Still the fat on-site fat is needed, but it's the error risk, fixes, repairing, modifications are minimized. So that's why I'm saying mimicking the between digital twin and Pinocchio novel, that it can become as smart as as close as the machine, close to the reality. If you feed the physics engine, you know the application, you know how your machine plant, your system works, and you feed the physics engine, then you are good to go, and it can be that smart. And when we are talking about simulation and emulation, one also clarification here. Simulation in Schneider and in this literature, in this context we are talking, is everything runs on my PC and the software environment of the digital twin. But if I'm saying emulation or academic term, hardware in loop, so means, okay, I'm interacting with outside devices, imagine PLC, imagine robot, imagine AGV, AMR. So the feedbacks comes from the hardware. I had one example, Sean, that the harbor cranes are expensive and dangerous application, and literally they cannot stop. It's I don't know, billions of dollars involved, and there's every single minute of the downtime regarding the operator training. So what we did with this digital twin, we put the real joystick for the operator training, real joystick, virtual digital twin of the crane at the harbor, so that the trainer can feel this more or less same experience as the real application. So in these cases, we can use it in IT and OT level as an electrical engineering. For me, if I'm on site, the current of the motor, I don't know, the temperature of the motor, frequency of the drive, these are important for me. Imagine in a Amazon or Walmart warehouse. But if someone is ordering the one product, I don't know, a bicycle or something, he or she doesn't care how much is the current of the current of the motor. So they just want to understand, okay, is my order submitted? Is my order fulfilled? Is my order is on the way to my home and so on? And or for example, on the Amazon side, Walmart side, they want to be sure that in a timely manner, for example, is that the order shipped out. So that's why we can have two approaches: IT level, like a order fulfillment, and OT level, the electrical characteristics in one word. So different users, different needs. However, if one model is developed, can be used on both sides, right? Because those components needed to fulfill the order, but different needs. So different level matters, like a simulation, IT and OT level. What else I can say? One thing also, it's for me as an engineer is a buzzword, Sean. Usually then saying augmented reality, virtual reality, or mixed reality, mix of both of them, which is good. I'm not denying it, but I want to say all of these. At Schneider also we have this kind of third-party Google's Android base, and we can, for example, mimic the digital twin in here. But this is only, I count it as only a display, right? If we have that backbone, digital twin backbone, base, fundamental, you name it, and then we add this display, different kind of display on top of it, then I name it just a display, not more important. And than that we can use it for the training purposes, service purposes, or usually when it's a dangerous and hazard area, people cannot go close to the machine and so on, then yes, of course we can use it. But without this backbone, I say it's more eye candy rather than the real engineering tool.
Yeah, whether you're training on a crane or training on an oil rig or many other systems, you need to do kind of the pre-training virtually, right? And we've all known about flight simulators for decades, right? But that's kind of the thought process there is you have to you have to do as much pre-training as possible before you get in the field, because that time in the field is so very expensive, right?
Right.
And a lot of times people, in the olden days, a lot of OEMs would just keep a show machine around so they could do tests on it, try different products and whatnot. And so, by going virtual, we just see there's just a lot of advantages to doing that. Not only by being able to test your production and make sure everything works right, but also for training as well. Let me turn it back to you.
Right, right. Very true. Thanks for your input. I agree with you. Um, what one other item I want to point on is that regarding the physics engine and so on I've mentioned, I can give additional example. Like, for example, on the object drop test, imagine on a conveyor or a cobot, if something drops, we want to show it. We can mention on the gravity and collision that object falls and bounces realistically and so on. For the cobot lifting load, for example, imagine torque and mass matters. If cobot, usually they have a limited weight capability and the payload, supported payload. So we can mimic those kind of things as well. Our conveyor belt jam is a very common issue, and the baggage handling, logistic, manufacturing, also friction and force comes to the game, and so on. That if two I don't know, imagine boxes are hitting each other, are they gonna fall off? Are they gonna sit on top of each other? What's gonna happen? We can mimic these kind of issues as well. What else we can say? We can say vendor agnostic here is very important. We are not living in a monopoly world anymore. So many big vendors, Schneider included, NVIDIA included. We will talk about the OpenUSD topic, that we should be able to devices can talk together, right? We cannot live anymore with the reasons in the beginning we talked. We cannot live anymore in the monopoly world and industrial network protocols. Also, the libraries, catalogs, and so on we have. For example, a digital twin software of Schneider. Okay, Schneider product is already uploaded there. However, it's a platform, not a software, a closed loop, closed software. Imagine third-party devices you want to should be able to communicate with third party and so on, create such a library and so on. Otherwise, it's not gonna work. And also, the importing some in this world also, MATLAB is very popular in academic and also in R&D and so on. If they've developed something, is good that we can bring that model to the digital twin world as well, in a functional mockup unit and functional mockup standard interface. These are the compatible and opens the door to communicate, this device communicate with the external devices, models and so on. And we want to have a fixed torque, fixed speed and so on one variable speed drive on a conveyor or and so on. So these are the items I can list as a selection criteria of the digital twin representative that we can help us to have a good virtual model. This tool can help us achieve this goal we talked about. And when we have this fundamental digital representative, next question is how we make it intelligent, and how we make it intelligent enough that can reason, decide, act. So this is the next topic that leads us to what is physical AI. Traditionally, we know that the AI creating, I'll summarize this article for me, right? This recommend me the steps should be taken for specific things and so on. We are all familiar, or even code generation and so on. These are, I'm not name it still commodity, but I name it different than the real value for the industrial automation. Although still have a different type of additional value proposition, but not directly to the industrial automation scenarios. But when we are talking about physical AI, is the AI that understands and interacts with the physical world through the machines, robots, sensor, actuators, and control system, right? In brief, we can name it, distinguish this from the normal AI, artificial intelligence, and the topic could be like a real time sensing, industrial data, I don't know, physics-based model. We earlier talked about this, computer vision, optimization, human in the loop supervision, and the examples could be like a robot picking irregular parcels, right? We are let me compare like a autonomous taxi or car and so on with our world. Usually they are going to the like a infinite cases, infinite let me put it in this way. In infinite situation may happen, but in our case, I'm not saying is a limited, but it's also not infinite. Imagine when we have a boxes damaged, bulge or dent and so on it. Or for example, a product is not labeled correctly and so on. We are still in the industrial automation. There are, but I've not seen a lot infinite data is needed and infinite cases to match. For example, if the model wanna make a decision, usually among the limited, maybe 100 cases, maybe 200, 300, but usually not infinite, rather than the unpredictable world. And for example, AGV AMR route optimization depends on the battery level, depends on the traffic, depends on the items they want to handle, and these kind of things could be use cases as well. Conveyor jam prediction, we talk baggage handling, dynamic warehouse dispatching, I don't know, vision guided cobot handling, autonomous fault recovery. These are the use cases. We can talk about this to, for example, find the bottleneck, find the quality prediction, find the maintenance prediction, autonomy detection, and categorizing. Usually, the simple example is in our bill, electricity bill, we have seen ComEd is charging us for the super peak or other supplier, super peak, off peak. So how I can to handle, I don't know how many thousands of packages, product, and so on. How can I save my energy, the cost I'm paying to the electricity supplier, to move my my tasks from the super peak to peak, or from peak to off peak? And or for example, if it goes above the certain limit, then I should pay more kilowatt per hour cost, right? These kind of simple examples, we can hire and optimize the procedure.
Yeah, I think if we look at like an AMR, right? There's
Right.
only a finite number of stations it can go to. you
Right.
know, if we look at a self-driving car, much more complicated. I mean, one of the major self-driving car companies had a presentation about 8 years ago, and they were showing examples that kind of tricked them up. Like a van was driving, but I had a bicycle mounted to the back of the van. And of
Right.
course, the car thought was trained that they should brake when they see a bicycle, in front of them, right? In that type of horizontal position. Those are things that somebody who's doing an autonomous vehicle, they have to actually take into account all kinds of crazy things like that. Like you'll see tractor trailer tractors where they have multiple tractor trailers stacked on top of each other. And to a self-driving car, they don't even know what that is. It looks like a car accident, right? Because all those
Right.
tractors are on top of each other. Whereas in our industry, right, our conveyors only go to so many machines. Our AMRs can only go so many different places. The AGVs have the spots where they go. Yes, they have to have safety sensors. We don't want them running into people, but they're so much more finite, and that's great because, as you were saying, that allows us to really improve and focus on what we're doing, so that we can improve and, like you said, save energy, increase throughput, better quality, and all those things. And let me turn it back to you. Hey, everybody, just wanted to jump in here really quick and thank Aidin for coming on the show, and also thank Schneider for sponsoring this episode so we could release it to you completely ad-free. I really appreciate when vendors do that. So if you see any of our previous sponsors, please thank them for sponsoring episodes of the show. And I do try to reach out to tons of vendors. As a matter of fact, I'm going to Automate next week to actually try to find new vendors to come on the show. But I could use your help. If you're out there and you're talking to Schneider or other vendors, there are some that I reach out to every month and they're like, yeah, we'll come on. And then it's crickets. So please help me out. Tell your favorite vendors. We want to see them on the Automation Podcast. We want to learn what they're doing new, and learn about their new products and technologies. And it would really be appreciated if you guys can help me out with that. And with that, let's go ahead and jump back into this episode of the Automation Podcast.
Very true, very true. Thanks for raising it up. And I want to add one use case, that's for the laboratories and so on, or dangerous area. We put the cobot on top of a AGV AMR that can go and do some tests. So additional parameter comes to the game, to this equation, which this kind of digital twin and so on can help a lot. Very true. Thanks for.
Absolutely.
Now let's go to we talked about the digital twin fundamental. We talked about what is physical AI, and let's take a look at high level major element of this physical AI. I can categorize them in three major topics: reinforcement learning, synthetic data generation, and deployment to the hardware. These three pillars, I want to talk about this and how it can. I'm talking about like a briefly what is that short definition, and then how it's linked to our digital twin story, and how it's helpful for this autonomy journey, automation to autonomy journey. Let me start with the role of reinforcement learning. Reinforcement learning is the approach where the AI agent learn and make decision as a machine learning approach, where agent can learn and make decisions safely and quickly through thousands or even millions of trial and error tasks. I looked at the IBM website. They gave a beautiful example of the trainer and a dog. Imagine trainer is an environment, and imagine a dog is a puppy is an agent. So based on the actions that the puppy is doing, environment or giving the rewards and penalties. So more and more the rewards are collected, this policy becomes valid and valid. Imagine the agent is the learner or decision maker, environment is the world the agent interacts with, and the action moves made by the agent and states the current situation of the agent, and the policies, the strategy the agent uses to determine the next action based on the current states. So always improving and always getting feedback to get better and less error and so on. So the agent observe the current state, and the agent perform an action based on this policy, and the environment changes, the agent receive rewards or penalty. So if the environment changes, again, it's adaptive, can be changed. So the agent update the policy to increase the probability to choosing the highest reward action in the future actions. So this is in brief how we can use the reinforcement learning with thousands or millions of trial and error. And digital twin, back to our fundamental, digital twin can be used as a single source of truth that these to provide, because it does already have the physics concept, formula and so on has not been changed. And we talked about it should be feed it correctly and so on. So we can use it as a single source of truth to provide, to train the model based on these rewards and penalty policy. So this is how reinforcement learning is connected to this. And the NVIDIA ISAC is one of the examples. I know we are going brand neutral. We are not talking about the advertising any brand or and so on. We keep it conceptual. However, just one introduction, if the people are interested to know, okay, what is the example of it? NVIDIA ISAC is the example of it that can handle this kind of tasks. And second part is the synthetic data generation. So in this way, we move from the real world to the virtual world more and more. So we don't need to go, imagine the mechanical things to change it, to set it, to do the test, redo the test, how much time and energy and cost causing us. So instead of doing it in a real world, thanks to the reinforcement learning and something like NVIDIA ISAC, we can do the test as much as we want with the minimum effort, let me say, and to do these thousands or millions of the trial and error to train our model. And one step behind this is the synthetic data generation. Imagine I have a production line, same production line, different rims. I have 10 type of rims. I want to select this type of rims and categorize them or send them to this distributor, one in Illinois, one in California, and so on, right? So usually it happens when they prefer to have one production line or several, as less as possible. Or if one production line failed, they can use the other one to be flexible and not stop the production and so on. So many reasons. Here I need to train my model with some what is good, what is bad regarding the penalty and reward we talk. Can I go and put, I don't know, the good one, the bad one, and so on? I should take a picture, take a test, and so on. So imagine even background light is changing. Again, is changing. Imagine all the products. Okay, yes, we are talking about cookie cutter things, but even cookie cutters are not all the same, and can be different. Or the boxes, imagine in a post and parcel, can be changed. So for this purpose, thanks to some, again, an example could be NVIDIA replicator, which can sit and communicate with NVIDIA ISAC, can generate for us thousands or millions of the synthetic data. And I can reuse them instead of I go take a picture and then bring it and I tell my mother, this is the good one, this is the bad one, this is the good one, this is the bad one, with so many variants and so on. We can do this with this kind of tools that is a part of the physical AI concepts. That's why we are saying why synthetic data generation matters. And the last step is we have the policy. We know the good ones and bad ones. We can interact with our environment, and we can know it's the time to go from the virtual world to the real world and deployment, which, for example, NVIDIA Jetson or Schneider EcoStruxure comes to the game, can deploy to the devices to do the shoveling, right? Still we need actuators. Sometimes, everything gonna be software. No, we are, okay, at my knowledge is short, but since I see something need to handle the load actuator of the contactor or pick up the load like a cobot, robot, you name it, these kind of things, move the asynchronous motor on a conveyor still needed. So at the end, we need to come back to the real world and the deployment to the targeted device and receive the data from the simulation of the cobot sensors we did and policy we define to the real hardware that those kind of ecosystems can do this. Two major topics left here. One is safety. One is human. In the beginning, we talked safety always the highest priority. So we can say the key question I want to ask here is, and then talk about them, is how do we validate AI recommendation? Whatever, even you write a prompt at the different AI saying, be careful, it may have some errors and so on, right? Still in a simple text. Imagine in a real physical world can make a mistake. So how do we validate AI recommendation? What actions can AI take automatically? What actions requires approval? What happens if the model is wrong, right? How do we protect against cyber risks and so on? As cybersecurity, I'm not entered to this, but still the case is out of my knowledge. But still is the case of, because we're gonna interact with the outside and always risk of cyber attacks, cyber security is always on top of each model, because simply because we had a use case that's each piece of this puzzle, server, real site, and so on, sitting somewhere. So we are still going outside, but I want to say cybersecurity for sure is in the game. But here I'm talking about safety of the operation and the procedure. How do we prevent unsafe optimization? Because sometimes we want to save some money, some time, and so on, but we put the human in the risk, or the expensive products and so on in the risk. So a few autonomy guardrails. I want to summarize my question and reply them briefly. What is autonomy guardrails? Safety PLC, safety sensors, and machine safety remains authoritative. So we are not getting rid of them. They are still the major important part of the game. AI cannot override certified safety systems. No. Human approval required for high impact systems. Simulation, emulation, or hardware in the loop required before major control strategy update. Audit trail required for the AI decision. Cybersecurity we talked about, and model drift must be monitored. And closing takeaway here is the autonomy must be bounded, right? Be bounded. The system can be optimized, but only inside verified safety, operational, and business constraints. It's not unleashed AI because of the reason we talked about it. And last topic we talked is the human. Because when we are talking about autonomy, people thinking, oh, we are going to the world that no human talks to human. No, we are still human. We talk to each other. We need this. Still socializing is a popular topic. No, it doesn't mean jobs get removed and so on. I think it's like the examples you mentioned, AutoCAD and so on. It's shifting, but still human in the loop is needed. For example, the goal is not to remove the people. The goal is to evaluate people from reactive firefighting to supervisory control, exception handling, strategy, safety, and continuous improvement. Humans are still essential for safety validation, operational priorities, exception management, governance decision, maintenance strategy, process improvement, trust calibration, final authority in high-risk actions. So in one word, autonomy doesn't mean absence of human. It means better orchestration between humans, machine, software, and AI. And if I want to summarize what we talked before closing, I want to give the floor to you if you have any question, comment, and so on, is that three major steps we talk. Testing simulation, run what if scenarios. What I mean, imagine you have an installed base logistic warehouse and it's a Black Friday, is a Christmas, and the pick is coming, or post and parcel like a FedEx, UPS. Pick is coming temporary. The people, imagine engineering manager want to know if they can handle this 30% overload, or if they want to reduce their cost of energy. If they go under load, what happened? So what if scenarios is very important, that thanks to digital twin and thanks to physical AI, we can mimic the behavior of the system and then deploy human in the loop. AI recommends, operator or engineer approved, and move to supervised autonomy. AI execute low risk actions automatically, and we can we call it digital twin in the loop, and monitor the behavior and optimize it. After 3 months, 6 months, I can say, okay, I can shift from the super peak to peak time and save these kind of things. So these are the link between fundamental and add-ons to have a modular approach, because costs matter, or a project manager or the end user wants to have a stepwise approach and phases, one phase at the time, can have this and link it with the look to the future. Oh, okay, I can have a digital twin with discrete engine now, and then for the cells, before cells and during the engineering specification, and then virtual commissioning during the engineering phase, and then during the operation, digital twinning, and then with the future physical AI, I put the physical AI on top of it to move from the automation to autonomy this journey. Floor is yours, Shawn, if you have any
No,
questions.
I think you went through it very well, and I think, to get back to the point you keep making, it's not about being George Jetson where you go to work, press a button, that's all you do all day, right?
Right,
If we look back at what's really happened, right? So I love to tell the story about a baby food company who makes the baby food in the little jars, and they had this really old multi-story brick building that they moved in, they actually sold and moved into this brand new state-of-the-art facility, huge. And when you walk in the door, right, along the wall they have a mural, and it's a picture of the old plant in the early days, right, during World War II or after World War II. And all you see is this, it seems like an endless table of ladies with hairnets cutting carrots or potatoes or something, because that's how you diced up your the vegetables and whatever's going into the baby food. They did it all by hand. And
right,
so that was good work back then, right? It was clean work,
right,
paid well, but that's not what people want to do today. And it would be kind of silly to do that too, because we have much better ways of doing that,
right,
right? Just like we don't want to go get a bucket and walk down to the local stream to get water. We have, a water department in our town that delivers fresh water to us. And so this is all about, as we learn new things and develop new tools, we want to use our time more efficiently to be more productive. And that's where I think, you see a lot of the solid works, a lot of mechanical engineers, I think, went to that because it gave them another way to visualize the products they were designing. And that's why I think, additive manufacturing to make rapid prototyping was such a big thing, because they could see it and touch it and hold it. Maybe that's not going to be the gear that runs the actual machine, but they could test it for fit, form, and function, make sure it worked and was everything, as they imagined it worked well. A lot less expensive to do with that than to order a custom piece or custom dies or custom machines to make something to find out it doesn't work. So I agree with you. This isn't about trying to, like, when I buy an office chair, I want a real chair I can sit in. I don't want a virtual chair that's going to live on an Xbox or PlayStation somewhere. I need a comfy chair to do my work. And so this is all about, it's not about just trying to hook ourselves all up to VR and, and live like, one of these dystopia future movies. It's about improving everybody's situation. It's about improving job conditions. It's about making them safer, making them, more making the people's, valuing the people and what they're doing versus having just do something repetitive. If we found a way to do that, automated, now they can move on to something else, right? They can
Right.
move on to being the supervisor, watching over the machine that cuts up the carrots and maybe even program the machine that does that. So and quite honestly, our kids today, my grandkids all grew up with tablets. They don't want to sit at a table cut vegetables all day. You just try to get them to do it around Thanksgiving, and it's hard enough, right? So I agree with you. This is all about us using the tools that we have today, like these new vision cameras where you can show it 100 bad parts and show it 100 good parts, and it's so much better than the self-teach models we had 20 years ago. I mean, they're so much better. And so, yeah, no, I agree with you. And I think this is a very interesting topic. And I love how you broke it down into the different pieces and parts. And I think, digital twins, it's not a one and done. You're going to constantly, just like you constantly update your PLC code to take care of new conditions you find, your digital twin's going to have to be updated. Maybe products change. Maybe the material changes slightly because there's an outage or the particular product has been found to be not safe and has to be replaced with a safe. So digital twins are not static. Design once always works. It's just like your programming code. It's just like your HMI and SCADA system. You're going to have to be updating it to keep it useful, right? And
Very
so that's just kind of my thoughts after listening to you and what you said. I think you're right on track with that kind of approach that you just explained and how this really transforms the physical AI, right? The autonomy, within those within those boundaries. We don't want self-driving cars driving through our living rooms, right? We got to put boundaries on all of these things, but it just made so much sense, and I really appreciate coming on. And I guess let me just turn it back to you. Any final words? Anything else you want to discuss before we close out the show?
Yes, I have a few closing words, but you brought out good topics as well, like a realistic one, because some in some cases we see that, for example, oh, physical AI can solve everything. No, what you said, the examples you said was a realistic, that like you mentioned, continuous improvement, continuous
Yes.
add-ons, continues. What if scenarios to optimize something? Imagine more production, less energy consumption, and so on. Yeah, I like what you said, and also, you know, regarding the look and feel of the software. Uh, Thanks to Pixar, Walt Disney, and so on, they did a great job for the animations. Very close, but they are not equipped with the physics engine. So more and more we are in the, because for the engineering, I don't care if it looks not realistic, if it's ugly. But for me, the like a physics concepts are more important, right? But also one part of journey visually, also they are getting better and better, and yeah, for example, NVIDIA did a great job in this regard. Yeah, I want to add this. That you brought up, raised a good question. A few words, like a closing and summarize what I said. Like the future of industrial automation is not only about adding more sensors or more robots and so on. It's about creating intelligent, validated, and connected systems can be understand the environment, test, decision virtually, and act safely in the physical world. So digital twin provides this virtual fundamental. Physics AI provide adaptive intelligence, so we can distinguish between them. And okay, wherever is needed, we can put this cherry on top of the cake. Industrial automation provides reliable execution. Together, they form the practical path toward autonomy. And the future of the industrial automation is not just automated, it's context aware, simulation driven, AI optimized, and progressively autonomous.
Yeah.
Sean, and my reference is that is the white paper I've written in co-authored with NVIDIA. I shared the link on my LinkedIn, is also available. I shared the link at the end. If the people, of course, we are living in a world that's knowledge is accessible, and this is beautiful. Maybe our ancestors, I don't know, 100, Mr. Genius Nikolai Tesla, Mr. Genius Samuel Morse didn't have access to this amount of data. So they can reference to this, or the references are used, or for example, NVIDIA site, Schneider site, and so on for further uh, um, information if they want to dig into that. For sure, the basic knowledge and so on is needed. If they want to, people want to start, it's good to start from the problems, uh, from their industry pain point, not necessarily from the technology, and then follow this path to find the right elements and effective elements to learn and hire these technologies to their benefits, to their company benefits, and so on.
Excellent. Yeah, and I'll just throw out there too the keynote with NVIDIA that was at the Schneider Innovative Summit. I found that so interesting. It's been 6 months already, but that was so interesting in how they're adding that layer of physicality that will enable us to tell it what type of materials the products are that are on the conveyors. So the system will know, the digital twin will know, hey, when will it start slipping? What weight or what type of rate will the product stop slipping and not go down the conveyor belt? So I think that's so interesting, and that's another resource people may want to check out. Of course, we can include a bunch of these links in the description as well. But with that, let me turn it back to you for final words.
Yeah. Every time you bring the good question, exactly, you are addressing the advancing the slogan on my background, advancing energy tech, right? Schneider is we are converting the form of energy, and Schneider have solution for, if we are converting from the electrical to mechanical, like a drive and motor and so on, or vice versa from regenerative, imagine in hoisting application, or we are taming and harnessing the energy with industrial automation to our benefits and so on. So exactly, you are talking about the Schneider slogan. Just finish. I just want to appreciate your input and having me, and I hope people can find the topic interesting and they can open a way for them.
Well, I want to thank you, Aidin, for coming on this show. This is a very interesting topic, and I'd love to hear from the audience. You guys have thoughts or opinions, whether they're the same or different from us, we'd love to hear from you. And with that, Aidin, just thank you again for coming on the show.
My pleasure. Thank you. Have a nice day. Ciao.
Well, I hope you guys enjoyed that episode, and I want to thank Aidin for coming on the show. You can tell he's very passionate about the topic and talking to us about his thoughts on automation to autonomy and digital twin-powered physical AI. Very interesting stuff, and we'll include links in the description as well. I also want to thank Schneider Electric for sponsoring this episode so we could release it to you completely ad-free. Really appreciate that. I also want to ask you guys if there's other vendors you'd like to see me cover. I'm reaching out to a ton of them, and I get a lot of crickets, and sometimes I get, yeah, we'll come on, and then I never hear back. So please, if you could reach out to your favorite vendors and tell them to contact me, you'll find my phone number and contact info at theautomationblog.com and theautomationschool.com and on LinkedIn. And, I'd really like to meet people. As a matter of fact, I'm going to Automate next week just to meet new vendors, to try to get them on the show, and so we could broaden the number of vendors we're covering here. And so any help you can give me, I'd really appreciate it. Also, if you're going to be at Automate and you want to meet up, let me know. I'm scheduling booth tours with the vendors, but also if you want to text me using the phone number at the top of theautomationschool.com, you can. So that office number, I've migrated to a second eSIM on my phone, so I'll be able to get texts on that public number. So please feel free, if you watch the show and you're like, Shawn, I'd love to meet up and just chat, maybe grab a coffee or something, let's do it next week at Automate. And with that, I want to thank you all for tuning in. I want to wish you all good health and happiness. And until next time, my friends, peace.